Hey guys, welcome to 1.8. This is the application mix problem of using arithmetic and geometric sequences and series. So before we start, let's take a look at our warm-up for today. The warm-up says, what is the difference between an arithmetic and a geometric sequence or a series, and how are their functions different? So let's list a few things. For arithmetic, you have the letter E, and it's all about adding and subtracting. Okay? And the formula for arithmetic series and a sequence. So a sequence means it's the order in sequential order. Who is going to be in the 25th place? Who is going to be in the 20th place? Who is the 19th person on the roster? So something in order. And the formula for that is A sub n equals the first term plus d n minus 1. Okay? A series is a total. I want to add everything up. And what am I going to get? There's three different ways. First one, you just add it all together. Number two, you can do your sigma. Okay? Where you have the first term plus your d, and then this is x minus 1, or n minus 1. Or you could use this formula right here, S sub n equals n divided by 2, your first plus your last. So that is an arithmetic. Geometric, on the other hand, has to have a ratio, and the letter we use for that is R, a common ratio. And all that is about multiplication and division. Okay? A sequence, the order, the formula for that is A sub n equals the first term times your R raised to the n minus 1. A series, which is a total, you have three ways to do it also. Add them all together. Use this formula, S sub n equals your first term, 1 minus r raised to the n divided by 1 minus r. And you can also do the sigma as well, except the explicit formula here is a sub 1 times r n minus 1. Okay? So those are the difference in the two, and they function very differently. This is a linear, and this one is exponential. So if you had a growth here, it just continuously go in a straight line. In a geometric, notice the curve. This is what you want in your investment. Okay, this one grows slower, this one grows really fast. Slow at first and then it shoots up, so this is more like retirement. And there you have your warm-up for 1.8. Please fill that in, take a picture, and submit it in the warm-up section of the Google Classroom. Okay. All right, our lessons for today. Here's our goal for today. Our goal is students will be able to solve real-world application problems with geometric and arithmetic sequences and series. So before you start, there are two things you need to know. You got to figure out, is it geometric or is it arithmetic? Am I adding or am I multiplying? And the other thing that you also need to know is, hey, am I looking for something in order, which is a sequence, or am I looking for a total, which is a series? Okay? Sometimes you hear the word sum. That's a total. So you got to figure out, is it geometric or arithmetic? Am I multiplying or am I adding? Constant. Am I looking for something in order or am I looking for the total? Once you know the answer to these two questions, you can pretty much do any of these. So let's start with example 1. All right, so here's the formula review. Okay, I'm going to add sigma to the arithmetic. X equals 1, n goes here, and then you have your explicit formula. Now, I noticed some of you guys put numbers where the n is. You don't put that. You put an x or an n, okay? But you don't put a number there when you type in using sigma. For your geometric, sigma, same thing. X equals 1, goes up to n, and then you have your arithmetic sequence. Like the one before, you put an X or an N here when you type it in. You do not put a number here. Okay? All right. So let's take a look at the first example, okay? All right, determine if it's geometric, then determine if you're looking for a term or a sum. A health club rolls its towel and stacks them in layers on a shelf. Each layer of towels has one less towel than the one below it. If there are 20 towels on the bottom layer and one towel on the top layer, how many towels are stacked on the shelf? Alrighty, so you start off with 20. It always helps to write the numbers. You have one less towels. As you guys can kind of see, I start off with 20, go down 19, 18, 17, all the way to 1. You are not going to have a negative towel, okay? Because it says, and one towel on the top layer. The question says, how many towels are stacked on the shelf? So you want to know a total. So if you are doing a total, you're going to use a series formula. And let's take a look at our data. Am I multiplying or am I adding? Well, you're adding a negative number. I'm going down by 1. So that is an arithmetic sequence, okay? So the formulas I have, I can use this one. If I use this one, I need to know the last term. Or I can use this one. If I use this one, I need to know the D. Either one. So let's take a look what we've got. So you can see a little bit better. That's a D. I should have used my yellow one. All right, here we go. So I'm looking for a total. I'm using arithmetic. I'm going to use this first one here. S sub n equals n. Well, how many n's do you have? Well, you 20, 19, 18, so your n is actually 20 divided by 2. Your first term is 20, and your last term is 1, okay? Plus 1. Type that into your calculator, just like you see. Let me clear everything. 20 divided by 2, oops, 20 divided by 2, parentheses, 20 plus 1. So how many towels do you have total? 210 towels. Don't forget to label. So if I did it like that, I'm going to get that answer. What if I did it a different one? What if I used the sigma instead? So let's see. You see that you were going to get the same answer. X equals 1, so I always need to see your setup. N is 20. Arithmetic sequence is 20 minus 1, x minus 1. Okay? Type that into your calculator. Here we go. Alpha window number 2. This is the x you use right here. X 1, right click, 20 layers, 20 minus 1, not negative, minus. Make sure you type everything inside your parentheses, x minus 1, in parentheses. And I get S sub n is 210 towels. Okay. As you can see, I can use this method or I can use this one. I get the same answer. Okay. So it's an arithmetic, so I'm going to use the left side. It's a series, so I can use either one of these two. And there you have it. All right, let's look at example number 2. Here we go. Heavy rain in Brianna's town caused the river to rise. The river rose 3 inches the first day, and each day twice as much as the previous day. How much did the river rise in 5 days? Okay, it didn't say how much did the river rise on the 5th day. It says in 5 days. So I am going to be doing a series questions. All right, so I'm going to look for a sum. So the first day it rose 3 inches. And each day, twice is times 2 as much as the previous day. So 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. And you can just do that on your calculator. Okay? Watch. 3 times 2 times 2 times 2 times 2. See, just like that. All right? It says it has been raining. How much did the river rise in 5 days? Well, day 1, 2, 3, 4, 5. So here are your options. I want a series. I can add all these together. That is probably the easiest one because there's only 5 numbers to add. So 3 plus 6 plus 12 plus 24 plus 48, which comes out to be 83 inches. By the way, there's 12 inches in a foot. That's almost 7 feet. Just thought I'll let you know. It's taller than me. What if I did it this way? S sub n equals, okay? So you have 1, 2, 3, 4, 5 divided by 2. Your first term is 3. Your last term is 48. See if we get the same answer. All right? 5 divided by 2, parentheses, 3 plus 48. What did I miss? I used the wrong formula. I sure did. This is an arithmetic. Notice I didn't get the same answer. Oops. Let's try again. First term is 3. 1 minus r. Okay. My r is 2. N. 1, 2, 3, 4, 5. Divided by 1 minus 2. Oh, I did that wrong. I forgot to tell you guys it's geometric because I have an r. I'm multiplying by 2. Alright, so here we go. 3 parentheses 1 minus 2 raised to the 5. Right click. Make sure you right click, bring it down. Divided by parentheses 1 minus 2. And I get 93. Okay? I'm looking for a total. 1, 2, 3, 4, 5. 3, 1 minus r, raised to the 5th, 1 minus r. I wonder if that should have been a 1. Okay. Keep going. Let's do it the other way. Alpha window, number 2. X1, right click, 5. And my geometric formula is the first number 3, parentheses, 2 raised to the x minus 1. That also comes out with a sigma. I gotta go check my number. Okay, let's check this one real quick. Maybe I messed up. 3 plus 6 plus 12 plus 22, 24 plus 48. Oh, I added wrong. Wish you guys had told me. Okay, sorry. I added wrong. So as you can see, you can do it all 3 ways. This method, adding it all together because there's only 5 numbers. This method, okay, using S sub n, the formula, or you can use your sigma formula. It doesn't matter, just show me one way to do it. I'm curious to know how I got 83, so let's go back up. Oh, do you see that? I typed in 14 instead of 24. So this is a good way for you all to check, okay? Alright. If I hadn't checked, I would have missed the answer for that. Alright, next part, and that's a calculator error. More than 380,000 people run in marathons each year. Matt is training to run a marathon. He runs 20 miles his first week of training. Each week he increases the number of miles he runs by 4. So I'm adding 4 every time. So D is equal to 4. So that tells you it's arithmetic. How many miles did he run in 8 weeks of training? Okay? So 8 weeks. How many miles did he run, not in the 8th week, but in 8 weeks of training? So how many miles did he run altogether? So this is also a series. Alright? So, if it's a series, I'm going to use this formula. X equals 1, 8 weeks. First number is 20 plus 4, x minus 1. I'm going to use the sigma because I like the sigma. Alright, let me get out of that. Clear. Alpha window. Number 2. X1. You can use the other one if you want to. 20 plus 4 parentheses x minus 1. Notice I don't put a number there, guys. Notice I use the letter X, and that's this X here, not the green one, okay? Enter. So in 8 weeks, he has run 272 miles. And there you have it. All right, I'm going to take one step and go a little further. What if he had said in the 8th week, okay, how many miles was he running in the 8th week? Well, then if that's the case, you would use this formula instead. Your sequence right here. If you were looking exactly on week 8, how many does he run? So a sub 8 equals the first term, 20 plus 4, 8 minus 1. Did you guys see that? And then you would type it in, 20 plus 4 parentheses, 8 minus 1. So on that week, the 8th week, he is going to run 48 miles. So make sure that you notice the difference in the two questions. But the question for this one was a series, so this is actually the correct answer. But I just wanted to show you, what if I were to ask you specifically in the 8th week? How would you answer that? And that's what you would do, okay? Please show your work. I need to know how you set it up, because I could have used Sigma. I could have kept doing this 8 times and added like you hit number 1 here, or you could have used this method, S of n. So just show me which method you need to use. 2 things. Are they arithmetic or geometric? And are they sequences or series? You got to figure that out before you start any of these. All right, you guys will do great. Don't forget your units. Oh, one more thing. If I ask for an explicit formula, okay, this would be an explicit formula, guys. You don't put a number there. Just keep that in mind, okay? All right, good luck. You guys will do great. I should be back soon. Bye.